Preview.
Hello everyone, welcome to Mqtt Studio. We are back again. Thanks for being with us last week. We got a lot of good feedback, a lot of questions, a lot of curiosity. I think that was the core purpose we started this show with. We wanted to create a platform where people who are makers want come together, learn about some things which are happening in the field. They also ask questions, they also come up with their own projects, and it's an open platform where everybody learns something. So today we're going to focus on some of the pieces which we talked at a very high level last week. So during last week, we showed you a robot which we had built. We're going to show it again. It's right here. This robot follows the hand movements which I do on top of the leap motion here. So we're going to show it. But today we're going to focus on the subscription piece, or publisher piece, sorry, which means the data which is going from Leap Motion to my laptop and from laptop to AWS Cloud. How does it work? We're going to go deep into that, and hopefully by the end of this episode, you'll learn how this piece is working end to end. And we have a special guest here.
Yeah, we have a special guest, and then you want to introduce yourself?
Yeah, and my name is Anupam Mishra. I'm a solutions architect here at AWS. I work with a lot of companies here and really enjoy what I do.
Yeah.
Todd?
So thanks, Anupam. My name's Todd Varland. I'm a solution architecture manager, also here in San Francisco, and enjoy helping customers platform onto AWS and build cool things like robot arms.
Hi, my name is Trevor Hikes, technical delivery manager here at AWS. I'm here for the free food. That's pretty much it. I do want to introduce, we have a new host, Alexa. Can you introduce yourself?
Sorry, I don't know that.
Alexa, introduce yourself.
I'm Alexa and I'm designed around your voice. You can ask me to play music, answer questions, get the weather and sports scores, create to-do lists, and much more.
I promise that wasn't a plug. But yeah, go ahead.
Great.
So we'll use Alexa in some of the episodes and see how it can learn. Let's mute it so it doesn't take our audio. Let's start with the demo. So we want to give a recap of what has happened in last episode in very, very fast pace, so people who are joining us for the first time today can catch up on what has happened so far. So last week, the high-level theme was what is the robot which we are talking about? What does that robot do? And what are the different pieces which go into it? So we have talked about a lot of pieces which go into it, mainly 4, and I think we gave a high-level overview of those pieces. In this episode, we're going to focus on the first leap motion, and we're also going to focus on how to send the data from leap motion to laptop and from laptop to the cloud.
And basically a sensor. So in the context of Internet of Things, sensing the world around, whatever the area is, and then publishing that into the cloud. So that's where sensors is the theme for today.
Yep, because leap motion is one of the sensors which can detect a lot of movements which people are doing, but there are a lot of other sensors which you can fit into the IoT projects you're building. Some of them could be temperature sensors, moisture sensors, proximity sensors. There are like thousands of sensors, and we're going to go deeper into how to use different sensors, but today's episode will be focused on leap motion. Shall we do the demo, Todd?
Yeah, let's do it.
Yeah. So a lot of people last time were saying we want to see the code which is running on your desktop. So what we're going to do is, while we do the demo, we also want to show the screen. Trevor, shall we switch to my laptop?
Absolutely. So when you were talking about other sensors, like I remember the hackathon we had at reInvent, where we had kind of competitions. There was one, a farming, it's like a farming invention, how it can detect the moisture in the dirt.
There's moisture sensors. There's, like Anupam said, proximity sensors, temperature sensors. In the simple beer service, we do a flow meter to tell whether liquid is passing through a tube. There's, 3-axis accelerometers. There's all kinds of interesting. We're going to, as we kind of go through the rest of this year, we're going to go deeper into different sensor types and talk about them. Some sensors are digital, some sensors are analog. We're going to talk about what that means. And so, anyway, are you ready on it?
Yep. So let's focus on leap motion for now. So there's a specific code which we have written here. What this code does is it's reading the coordinates of hand from the hand. So let me start this.
And so this is basically motion controller.
So I started a script which is publisher.javascript.js. So it's running a node script. And when I put my hand, it's printing a lot of things. So there are different frames which are coming from leap motion, and they're telling us my hand state. So the thing which is important here, let me stretch this window a little bit. 1 minute. Okay. So as you can see, there are 3 distinct things in the coordinates: x-axis, y-axis, z-axis, and hand state. So we're sending these parameters. As you can see, if I twist this left and twist it right, these things should change. As you can see, x-axis is becoming a big number. Sometimes if I twist this side, it changes again. Similarly, if I take it up versus take it down, y-axis should change. Same goes with z. Now let's check the hand state. If I close my hand, the hand state changes to 2700, which is a number which we have hard-coded to understand the hand is closed, and then similarly hand open. So all these things are being recorded from this leap motion, and they are being sent to AWS Cloud. So far, the data is on laptop, and it has been pushed into cloud. Now, what happens next? So now that this data is going, let's look into how the subscriber, which is the Raspberry Pi here, let's move Alexa a little bit here. So we have a Raspberry Pi here. As you can see, let me lift it a little bit. So there's a Raspberry Pi. This Raspberry Pi is connected to the robot, and this robot is the one which is telling these arms how much to move. So it has different motors, and to different motors it tells how much movement they should do. So let me run the subscriber here. So as soon as I run, we bring it to a specific location, and it came up. And as I move my hand, as you can see, the same signals which I am sending from my laptop are going into my subscriber. So the window which is in the front, this is the subscriber window. So as I move things, these movements are going into the Raspberry Pi via AWS Cloud. So it's using AWS IoT. Now let me move it down. As I'm moving down.
One sec while you're talking on the phone. 1 sec.
Sure.
Just do a visual right now. 1 sec.
Sure. So as you can see, I just picked an object there. It can move left, right. I picked puppy because last time we had a polling, and people who were saying puppy were not happy with us. They said, why didn't you not pick puppy? So this time we just wanted to pick puppy. But as you can see, this robot can grab different objects, and there are a lot of possibilities with it. This can move physically. This can react to things which you are doing in your office and replicate those in your home, and a lot of other things. So now there are a few basic parts here: leap motion, laptop, AWS Cloud, and the actual robot. And today let's focus on leap motion and this. So before we go there, are there any questions, Trevor?
No, so far we're just having some dual echoes, so I just went back to the main screen.
Yeah.
Sure.
Do you have the diagram?
Awesome. So let's show the diagram.
So while Anupam's bringing up the diagram, so the leap motion is connected to Anupam's laptop, and we're actually publishing this data into the AWS IoT cloud in Virginia, and then the Raspberry Pi is subscribing it back here in where we are today, San Francisco, California. So this data is literally going from here across the United States and back again in about, what do we say, about 80 milliseconds?
Yep. So depending on which region this data goes to, the latencies will change, but it's very, very low. Trevor, do you want to show my screen once?
Yeah, just to show the diagram.
Yep. So this is the high-level architecture of.
1 sec, just be mute for a second. Let them look at it, and then I'll go back to the main screen. Okay, go for it.
Cool. So the 3 pieces which we are going to focus on today are leap motion, laptop, and the piece which is cloud. So how do we connect? So to understand those pieces, I think there are a few things we need to understand. what is the protocol in which the laptop talks to AWS Cloud? How is it secure? Like what prevents other people from listening to the messages and understanding what's happening? So there are a lot of pieces which go into it. Todd, do you want to start with the security? Like how is it secure?
Yeah, so there's really kind of there's four main pillars of the AWS IoT service, and one of what we're going to dig into today is securing the devices and securing the communication. And so it's kind of important to talk a little bit about, well, security or securing, is a super high priority for AWS and helping our customers. But that also, in this context, what does that mean? And so the core things that we're looking for here is that we can keep the communication private. So in other words, any data that we're transmitting from the sensor, in this case the Leap Motion, into the AWS Cloud and back again, we can keep that from anybody being able to observe that in the middle, so to speak. Then the other part then is also being able to be confident that the data is not altered in transit. So keeping it secure and keeping it unaltered as we do this. And then the other thing is thinking about this at scale, because with just one laptop and one robot arm, probably not a big deal. We could probably figure out how to secure that. But when you have hundreds of things or thousands of things or millions of things, then doing it at scale then becomes really challenging, and that's where kind of AWS IoT gives folks kind of a lending hand. And so how do you do that? Well, back in the day, the thing that the way to secure data was to encrypt it, or still is to encrypt it. And the traditional way was then, if let's say Trevor and I were going to exchange information, what we would do is we would figure out some secret that we were going to use to encrypt the data. We would then agree and share that key back and forth, and then we would just encrypt our data. Well, that doesn't really work very well at scale when you have, like I said, hundreds, thousands, millions of devices. And so in the 1970s, this idea of public key cryptography was invented. And so what I'm going to do is use go very, very low tech. And Trevor and I are going to kind of explain how public key cryptography works. The goal here is to kind of demystify this, and then with it demystified, then it'll be easier to then build your own robot arms or connected device and use AWS.
Yeah, and I think the reason we are going into basics is we were checking from some people who joined and who watched. I think the youngest audience was probably 5-6 years old.
Yeah.
Somebody had a kid who was watching with them and learning about what robots can do. And
then we had and then somebody else was 80. Wow. So we were ranging from 5 years old to 80. Probably a lot of people in the middle. So we want to make sure and kind of cover how this all works. And so what Trevor and I are going to do. So we're going to act like, let's say I'm the Leap Motion and Trevor's, let's say, the AWS Cloud or another device. And Anupam is this mischievous person on the internet that wants to maybe intercept our data or view our data. So what we're going to do is, Trevor and I, we're going to do what's called, we're going to run this little program locally. If you can't read this, it says generate key. And through this little program, what we're going to do is we're going to generate, and this is all electronic, is generate a public-private key pair. And what these are is basically these are keys or long strings of digits. And these two keys, the public portion and the private portion, have a mathematical relationship. And so Trevor has generated a key pair, I've generated a key pair. And then what we're going to do is each of us are going to take the public portion of our key pair, and here you go. And what we're going to do is we're just going to post it on the internet, and we're going to have Alexa hold it for us here. Give me your public part.
Yep.
Okay, so this solves the key distribution issue. We're just going to make our public portion available. Just post it.
So
for
everybody
anybody.
knows about
Everybody,
public keys.
yeah, just totally out there. But then the private portion we're going to keep just to ourselves. And so the key is you don't share. There you go. So then this little kind of text string, it says a message I want to secure over and over again. So the way that I'm going to
what kind of message?
It could be, typically it's a text message, but it could be really any kind of digital file, really.
Okay.
So in this case, it's just going to be, in the case of the robot arm, it's a JSON file, which is text. And so we'll use that kind of example as we go forward. So the first thing I want to do is have non-repudiation. In other words, that each of us can be confident that the message wasn't altered. So what I'm going to do is I'm going to take my private key and I'm going to sign the message. And so that puts a digital signature on it. And then I'm going to take Trevor's public key and I'm going to encrypt the file. And then I'm going to send this, I'm going to pass this right in front of Anupam so he actually can't read it.
I can't read because it's encrypted.
Yeah. And you can't alter it. And then
so you'll take out your private key.
What Trevor's going to do is he's going to take out his private key and decrypt the message, and then Trevor's going to take my public key and verify the signature. And that way we've just passed a message across an unsecure channel, the public internet, and Trevor can be confident that the message was not read and it was not altered in between. So that is our super low-tech demo of public key cryptography. So anyway, hopefully. So do we have any questions?
So Desmond Bradley said, I remember when Phil was writing PGP many moons ago.
Yep, PGP, yep. So I think, in this kind of modern age, securing data is becoming increasingly important. And so anyway, so it's good for folks to know, the basics of how this works. So anyway, that's.
So how does it relate to SSL? Like people talk a lot about SSL, TLS these days.
Yeah. So AWS IoT uses TLS, and kind of the easy way to think about it is TLS is kind of the next kind of the continuation of the idea of SSL, and so this anybody that uses a browser when you go to a site that has SSL enabled, your browser typically will have a little lock or some indicator that says that you've got a secure communication. Well, that infrastructure and that what's happening behind the scenes is public key cryptography. So that's really we all use this on a daily basis, and so it's great to understand how it works.
Yeah, whenever we are opening HTTPS websites, this is what is used.
Exactly.
Awesome.
Exactly. So in the context of AWS IoT, and Anupam's going to get to this in a few minutes, is there's going to be 3 files that Anupam's going to download and generate, and that's an X509 certificate, then the private key, and then the root certificate for the AWS IoT service. And so the X509 certificate is the public key of the device that's created, and then that's bound to the identity of the name of the device. Yep. And so that gives us some great capabilities for fine-grained management of the device through the AWS IoT service. So then the only other requirements are TLS 1.2, that's the minimum standard, and then the data that you're going to send, and then the AWS IoT SDK, which in the example that we use here uses the Mqtt protocol.
What is Mqtt?
So let's assume for a moment that we have confidence that our channel their device is secured, the communications are secured, they're not altered. Then we need a protocol or an agreed way between clients and the cloud, and then the cloud back to clients or devices on how are we going to transmit that data. And one that's very, very popular, or a protocol that's very, very popular in IoT is Mqtt. And so Mqtt is designed to be very lightweight. In other words, the code necessary to implement Mqtt on a device requires a very little compute and very little amount of memory. That's important because oftentimes the devices that we're using are very low power. And it's very lightweight, and it doesn't send a huge amount of data just for itself to manage the communications. And it has this idea of publish and subscribe. And this is really important in that that the AWS IoT service provides this idea or this capability of an MQTT broker, which Anupam is going to talk about on how to decide what devices are able to talk to and receiving data from other devices and the cloud, vice versa. So MQTT really, it's about reliable communications over wireless or satellite or the internet, very low footprint, and has great capabilities around connect, disconnect, publish, and subscribe. And it's also really important to know that it maintains an open connection. So once a device connects to, let's say, the AWS cloud or subscribes to the AWS cloud, it keeps a connection open. And what that means is then you can do bidirectional communication. So the device can send telemetry data into the cloud, but then also the cloud has the ability to send control communications down to the device to say something like move right, move left, move up, move down. So anyway, those are some of the key attributes of the MQTT. There are other protocols, but this is the most popular and what we've implemented in the robot arm.
Do you see HTTP also used at places?
Yeah, sometimes HTTP is used. It's different in that it's stateless, and so the idea of HTTP is at its most basic level is you make a connection, you request some data, you get it back, and that communication is torn down. And so it doesn't really support this idea of bidirectional communication because it's meant to do a single transaction.
Yep. So if the device was running on battery, it'll probably consume less battery if it was MQTT than HTTP.
Yeah, and there's different things that you can do around how often you're doing the keep alive and this and that. And so really what it comes down to is what is your use case?
Yep.
If you want to be able to send a message down to the device, pretty much at any time, then MQTT is a good choice. If, let's say, you know that you're only going to send a message once a week, so then at a specified time or once a day, then you can just have the device make an HTTP connection, grab whatever message you want to provide it, and then it effectively disconnects. And so it really depends on what you're trying to achieve, effectively the use case.
Yep. Any questions from audience, Trevor?
So far, we have Desmond Bradley, not yet.
Okay.
He literally said not yet.
Oh, okay. So just for if anybody joined recently, today we are focusing on how data goes from Leap Motion to laptop and from laptop to the cloud. So whatever Todd just described tells us what is the importance of TLS and encryption, and what is the protocol which is used for sending this data to the cloud. Now what I'm going to do next is...
We do have one question.
Sure.
Spaz Christ said, what about MQTT versus WebSockets? Haven't heard of MQTT, but it seems it's a lot of a more specific thing.
Yep. So I've seen MQTT run over WebSockets. So WebSockets is a new way, it's not very new, but what it allows you to do is send push messages from server to the client, and you keep the socket open. MQTT can run on WebSocket as well, so they both run hand in hand together, and this is something which AWS IoT service supports. And in some of the future episodes, we're going to go deeper into that.
Cool.
Okay, cool, awesome. So let's learn whatever Todd just talked. Let's put that into practice. Like whatever he talked, how do we apply that knowledge, and how do we use whatever things he's talking? So for that, I'll need to show my desktop. Is it possible to show it?
We're getting a lot of echo, and we tried resolving it, but what we'll do is do
How
some.
about you do an imagine if?
We can share this.
Because I'm gonna do some screen share, like log in into some.
No, we can share like a screenshot and share the information, or share the screenshots later.
Sure.
Okay.
Yeah. Okay. Shall we? Yeah, I'm just thinking if we can.
Unless you want to carry your laptop and go to the camera.
We can try that. if that is our last option, let's give it a shot. Okay. Shall we give it a try and see whether echo can be resolved? Like maybe we turn off our video and just one shot, because that will smooth a lot of things. If not, I'll just come near the camera.
All right, we'll give it a shot. All right.
Turn off our frame just in case. That's the one.
Our frame?
Yeah.
It's only one frame right now.
This thing. Is there an echo right now? If somebody from
It's going to take 10 seconds.
turned off the volume.
We did that, Spaz Christ, and I'm not sure what happened. It was working right just before we aired. Everything was fine.
Is it?
Not sure what happened.
Is it okay now, or it's?
We're waiting some feedback.
Sure. Let's see what the audience.
There's
says.
no echo. Oh, there you
Wow.
go.
Awesome.
Okay.
So that saved
We
the
need
day for
a
us.
Spaz Christ to bless us.
Well, thanks a lot, guys. So what I just did while the screen was not shared is I just logged into my AWS console. Once you log in, these are the services which you see. There are a lot of services which you have. The one which we are going to focus on today is AWS IoT. So we'll just
And just after you do this, go back to the diagram so they kind of go back to see what
sure. Yeah.
they're looking at.
So let's go back to the diagram. So this was the full diagram which we had,
You can move
which
it one
is
if you want.
data going from Leap. Let's do it here. Data going from Leap to the laptop, from laptop to AWS IoT, and Raspberry Pi has subscribed to AWS IoT, which means it's constantly listening about what is happening. And then whenever some activity happens, it sends that activity to the Adafruit servo hat. What this servo hat does is it lets the servo motors move by a specific degree of movement. We can tell which motor should move how much, and that's how this robot is moving. Now, what we
So
have...
this is the same robot and Adafruit we showed in the first episode.
Yeah.
Yes. So we have two robots here, as some of you might have noticed. There's one big one and one small one. The code is same for both of them. There's not much difference on the sender side. On the subscriber side, we have some specific things which can be understood by these motors, but not understood by them, and vice versa. So the piece which we are focusing on right now is how does data go from Leap to laptop and from laptop to cloud. So let's focus on laptop to cloud. Now that we understand some of the background which Todd has given, let's see how laptop can send data into AWS IoT. So that's what we're going to do now. So first, I'll go into AWS console. I'll type AWS IoT service. Once I'm there, it shows me a dashboard of a lot of cool things. One of those is how many messages I have published. So I have multiple devices which I've used before. So it's telling me there are 13 successful connections. It's also telling which protocol I'm using. So as you can see, it can use Mqtt, it can use HTTP, and it's telling which type of connections I'm having: connect, ping, publish, what kind of methods have been called.
Why would that be important to show?
So I think it's very important once you have a fleet of machines. So imagine that you have 10 robots deployed at different places. You want to see how many of them are alive, like are still connected. How many of them are constantly sending data. So you can see how geographically distributed those things are and whether they are active or not. Then messages published, how many messages have been published, how many rules have been executed. We are not talking about rules today, but we are going to go deeper into in some of our future episodes. Same with shadows. This is a way of updating your robot or getting status from robot. So we are not going there. Let's first understand what happens here. So there are a few options on the left. One is connect, registry, security, rules, test. The part which we are focused on today is connect. How do you connect it? So there are three options. We're going to use the first one, which is configuring a device. A device can be a laptop. It can be a physical device like Raspberry Pi or Intel Edison or any other board of your choice. So I'll say get started. So when we get started, it gives us the various options. The first one is register a device. So first we need to register a thing. A device can also be called thing. So whenever we call thing means it's a device which is living and talking to the cloud. And the second one is download a connection kit. So it will give us some download options. And finally we will test it, whether it's working or not. So let's get started. So first thing it's asking me is what platform you have. So either it could be Windows or Linux or OS X based platforms. The laptop which I'm using today is a Mac, so I'm going to choose OS X. Then the second option it gives me is which language do you want to use. I can use Node.js, I can use Python, I can use Java. I think let's start with Node.js, and if time permits we'll go into Python, but we'll give you enough pointers to use other languages as well. So let's start with Node.js. So the second thing it's asking us is...
I guess for the users that are I guess, a little bit of beginning on this? Is there a reason to pick Node.js over Python or Java?
No, so every language has its own benefits and pros and cons, let's call it. And some of the popular things which I've seen in the world of IoT, a lot of them are either Node or Python. Those are the two common ones. Java can also be used. Java is very popular in enterprise world. Thinking from the experience which I had as being an engineer at Amazon, I would say a lot of teams use Java. Like Java is very, very popular when a high scale services are being built. So Node.js, I think I would say I wouldn't prefer one over other. I would just say Node.js is as good as Python in this case. We are just sending the data. So whatever language you are comfortable with. The one thing to understand though is when you use a language, there's a specific type of SDK, which is a software development kit, which comes with that language. So depending on which SDK you use, you'll have to write a little bit of different code. So in this case, our SDK would be Node.js, but if we had chosen Python, the SDK would be a Python SDK. So let's start with this. Let's give it a name. Let's call it Maker Studio Laptop. Let's call it that.
We can have the audience name it.
Sure, yeah.
Oh, too late now.
Oh,
Thanks.
okay, we missed on that.
Thanks, Anupam.
So we gave it a name. It's called Maker Studio Laptop. Now, there are a few things here. The first thing it's saying is the thing name is Maker Studio. As we know, this is the name which we just gave. Let me increase the font a little bit more. And the policy to send and receive messages, which means what permissions this laptop will have. So once we have this code running on the laptop, what things this code can do. So we can restrict what is allowed and not allowed for a specific device. So let's preview it. It's just for our understanding. It's telling that it can do a publish, it can do a subscribe, it can do a connect, and it can do a receive. These are the only 4 operations it can do. It cannot do anything outside of these.
This is one of the benefits of what we talked about earlier with having the keys that we're going to download, and then combined with AWS IoT, is we can get very granular about what devices can't do, what data they can see, not see, right?
Yep, that's true. We can make it more restrictive or less restrictive depending on the use cases which we have. The next option here is telling what the kit contains. I think it ties together whatever Todd explained. There's a certificate and the private key, the things which we just talked about. It has a SDK. So in this case, because I've chosen Node.js, it has a Node.js SDK included in it. And it has a script which allows us to look and do some experiments. So let's download it. So it just downloaded something. And I'll go to the next step. The next step is to verify certain things, like configure and test your device. So what I'm going to do is, let's just follow these steps. So it's saying first unzip the thing which you just downloaded. So let me go to the location where this is. So this was downloaded on the downloads folder. So I'll open my terminal. Let's make it clean. I'll make it.
Is it normally dirty?
I had 2, so I'm just okay. That's clear. So I'll navigate to my downloads folder. In my downloads, I see a lot of things. So let's clear it. What we want to do here is, first we want to unzip the file which we just downloaded. So when I unzipped, there are a lot of things which came. Things like connect device.package. Actually, let's do one thing. Let's do not to confuse with my previous things. What I'll do is I'll create a new folder here, mkdir. Let's call it Maker Studio. Okay. What we'll do is we'll navigate to this Maker Studio. We'll copy the file which we just downloaded, cp:/connect.zip. We'll copy this guy here. So we have our zip file here. Let's unzip. So now what I'm doing is I'm just following the steps. Let's look at the steps here. So first thing it tells us is unzip this. So let's unzip it. Unzip, connect. Okay, so it got a bunch of files here. As you can see, one of them is certificate file. One of them is private key, public key. And then we have a star.shell. So we have 4 files. The second thing it says is chmod +x star.sh, which means it's telling, hey, by default, the files which we download from anywhere most likely don't have execute permission. So why don't you give execute so your star.shell can work? So I just gave it a execute permission. The third thing it says is star.shell, run it. So I'll try to run it and see what happens. So I just ran it, it's installing something, it's installing the AWS SDK, and ran into an error. So let's see what is the error. It says the Node.js module is not set. So for those of you who are just starting with Node.js, it's important to know how to find it. So I'll just type install Node.js. If you go here, there's a nodejs.org Macintosh installer because I have a Mac, and this triggers a download. There's a specific package which just got downloaded. I can open it, and I can just click through some of the next steps, and it will install Node.js on my laptop. I agree, continue, and I'll put my password here. So voila, I think it's almost there. So it's installed. There are two things in Node. For those of you who are learning about Node for the first time here, there are two things. One is NPM, one is Node. NPM stands for Node Package Manager. Think of it as a library which has all possible packages already available. So you just say npm install, and it finds all the packages which you need. And similarly, Node is the one which runs the actual Node engine. So we'll move the binary to trash. Let's get back to where we were. Now, because we are in this folder, the package is not installed. So first we need to check what version of Node we have. So if I did node -v, it's 6.10.3, latest one. What I'll do is I'll do an npm init, which means initialize a project here. So it's telling me what name you want to give to the project. By default, it will give Maker Studio, same as the folder name. Then there are a lot of options it gives us, like what is the version, what is the description, what is the entry point, what is the test, what is the Git repo, what are the keywords, who is the author, what is the license. So I've skipped all those. By default, we'll just put empty. So what this just did was it created a package.json file for us. This is another new thing which some of you who are seeing Node.js for the first time. There's a package.json file which contains a lot of information about what is contained in that package. So for now, it is just the name of the project. Now the next thing I'm going to do is I'll run my start.shell again. Let's see what happens now.
Now, while this is going up, curious. We had a question from Desmond Bradley, and he was saying, just like off topic, how would one do for an object that's positioned in the outdoors to within 1 to 2 feet at a range of 1,000 yards?
1,000 yards?
Yeah.
Yeah, so that, there's probably lots of different ways to do that. There's different kind of technologies like LiDAR and other things.
Oh, LiDAR would be interesting.
Yeah, LiDAR. So maybe that's something we can cover maybe in a future episode.
So they want to control a robot which is 1,000 yards away?
Well, I think to sense
to
something.
detect an object that's either 1, 2 feet away or 1,000 yards away.
Yeah.
LiDAR is a good point.
And then anyway, so I think, doing it like without touching, without actually being there. So I think that's a great question. I think we should take that as input for a future topic for an episode.
Yeah, because like infrared would be too much, I guess, it'll be too much in the way. I don't think it can detect something that far away, 1,000 yards.
Yeah, so there's some interesting technologies that we can dig into.
Pretty cool, yeah.
Yep. Yeah, so I think, who asked this question?
Desmond Bradley.
Desmond, if you can send us more description about the use case you have, I think we'd love to have it covered in more depth. Our email ID is aws-twitch@amazon.com. We would love to hear more description of what you're planning to do there.
Yeah, we'll cover the inches as well. If you want to email us, just like what Anupam said, or you can actually send us a tweet as well directly.
Yep. So our purpose is to start simple, and then we'll make more advanced robots as we progress. So this is the things which are covering right now are very, very core, which will be used no matter what robot you build. So as you can see, I just ran the script. It's doing a bunch of things. It's saying connect, which means it's connected. And if you look at my browser window, it's sending some numbers like 29, 30, 40, a lot of numbers are here. So what I can do is I can either send, let's keep two windows open together. So I can, because my client, this terminal is now my device. So I can send a message to my terminal. I can say, hello from Maker Studio. Maker Studio. I just send message, and as you can see, it just got the message. So this client is connected to the cloud. It's listening to all the messages which the cloud is generating or receiving, and then it is also sending some publishing, it's also doing some publishing to the cloud. As you can see, these numbers are increasing. These are increasing because this device is sending the data. Now I'll go a little bit quick. I want to show what happened in this device, this script. If I look at this file, it's very, very, let me increase the font size. It's downloading a certificate. This is the piece you can skip for now, but this is the core of it. It's running a program called deviceexamples.js. For those of you who want to understand what is happening behind the scenes here, I would say just go to your favorite search engine and say AWS IoT.
Behind the scenes or behind the screens?
IoT Node SDK. Let's do Node SDK. Yep, AWS IoT. So we have a GitHub repo. It's called AWS IoT Device SDK. This script just ran a program called deviceexample.js, and actually we can quickly look into it. I'll not go into details unless people ask.
I mean, we're running out of time, but we'll share this information after.
Sure. This is the file which it just ran, and it has very simple things. It's just subscribing and publishing. I would highly encourage you to look into it, and in the next episode we'll cover this. So now let's now that we know how to send data and receive data from cloud, let's learn about leap motion a little bit more. So if you want to learn about leap motion, I think the best way to start is just search for it. So what I did was leap motion. Let's say let's call it install v2. So let me tell you about v2. So the device which we have, this is called Leap Desktop. They have many more devices, and this is Leap Motion Desktop. It's running a version of Leap called SDK v2. If I go there, it'll show me how to install it, what are the different things it can do. Think, for example, v2 tracking. There are different downloads I can do. Because I'm on Mac, I'll again do a Mac install. I've already done it, so for this piece I'm not going to install it. It's just doing some downloads. But now you can assume I have already installed it. But what install gives you is a very cool thing. So let me show you a visualizer. So once you install this, you'll see a window on the top which shows a lot of things about this. So let me show you a visualizer. Like what is it visualizing? So as you can see, if I point it towards start, it's looking some hazy images here, right?
And Martin's going to
looking at. So
you lost weight.
There's some cameras, and this is a cool piece. Now in my hand, it's looking at all the bones which I have. Like what are the?
Well, not really your bones.
it is extra
radiation.
Yeah. Look at that. Like how cool is that? Now having understood.
Close your hand.
If I close, it knows it. If I turn it, it knows it.
Punch Todd.
I can do whatever I want. So this is like awesome. The best part of this is the SDK allows you to check each and everything. Like where's my thumb, where's my finger, where's my palm, and this is one of the best pieces of hardware we have seen. So let's have our Leap Motion guest Martin here.
So Martin, you want to come on and
let's learn more about
Leap. So while Martin is getting jacked into his mic.
Alexa, what is leap motion?
Leap Motion Incorporated is an American company that manufactures and markets a computer hardware sensor device that supports hand and finger motions as input, analogous to a mouse, but requires no hand contact or touching.
Pretty good, Alexa. Pretty good. Some updates to that, but that's the general idea of it. Yeah, so to tell you a little bit more about that.
Well, why don't you introduce yourself first?
Maybe I'll introduce myself first. So hi, my name's Martin Schubert. I'm a virtual reality designer at Leap Motion. So what I do is I focus on, at the moment, Leap Motion, we have desktop tracking, which you've just shown off, and the future for us right now is virtual reality, augmented reality, and mobile VR. And so I make, at Leap Motion, I make virtual reality experiences that use your hands as the input. So the video that you've got going down in the corner there is a video of a demo I recently finished. It's doing some fancy mixed reality filming. So you can see that I'm wearing a VR headset in there, and I've got a Leap Motion on the front. And on the right, you're seeing the view inside VR. So that's my hands being tracked by the Leap Motion sensor. And in this demo, it's this rainbow visualization, for example.
Oh, cool.
But yeah, so maybe I could show you the visualizer and talk a little bit about that.
Yeah, so I think one of the things which I always wanted to understand is this is doing a lot of cool things. Can you tell us how is it working? What is the magic behind all this thing?
Definitely. So if I can grab that one,
Sure.
actually, can we share the screen again?
Yeah.
Might be a little bit easier to explain. So Leap Motion, the hardware is actually really simple. So there's 3 infrared LEDs in here that are shining out infrared, and then there's 2 cameras. So if you look on the screen there, you can see that's one of them, and then that's the other one. And those are capturing images at 120 frames a second, sending those images to the computer, so in this case the laptop, and 120 frames a second, it's tracking your hands as a full hand skeleton, like you were saying. It's not tracking your actual bones, but the way the tracking works is, so we've got these infrared LEDs shining out infrared, the camera is picking up the black and white image, sending it to the computer, and then our software, which is really the product, is what's able to track your hands as 26 data points with individual position and orientation. So each of these little red balls that you're seeing, that's an individual tracking point. And the way that we do tracking is a combination of a bunch of different things. It's computer vision mainly, and a bunch of other new things which are sort of a little bit of the secret sauce of how Leap Motion does the tracking. But also an important part is knowing how a human hand works. So people ask us a lot, oh, can you track arbitrary objects? Can you track feet? This is another one that we get a lot. And at the moment we're focused specifically on hands, and that's why we can track hands at this really high fidelity. Also on the monitor there, I'm not sure if they're seeing it the same way, but tracking is actually pretty smooth. It might be a little bit of the...
It might be a little choppy on the screen.
Right, yeah. But usually, one of the tests for how fast the tracking is and how accurate it is, here, you're holding your hand over a device and you're looking at a screen. You're looking at a 2-dimensional representation of your hand, and you're waving your hand over here.
So when you put your hand down right here, it was able to detect what you were doing.
Oh yeah, so let me finish talking about this piece of hardware. So the cameras in here are 135 degrees diagonally. So you can see over here, I can go...
Can I have like a lot of hands on top of it? Like
there's a setting, yeah, if you put your hands in, it normally can track as many hands as it can see.
yeah,
Oh, wow.
I've got 4, yeah.
So the software it's looking for hands. It's analyzing, at 120 times a second, it's analyzing these images to try to pick out hands. And that's why you can see here that even if I hold it up to my face, it's looking for that specific wavelength of infrared. So it's trying to mask out the background images, and just, if it sees a hand, it tracks it. And then you can use that information for whatever you want to use, like the robot or something else.
Yeah, we covered the device also in our first episode, and so it's true. Like the device itself is it's simple. Anybody can build it, but the real magic is in the software.
Well, so the software runs specifically on our hardware setup,
Okay.
but the idea with the hardware being simple is, like you mentioned LiDAR
Yeah.
sensors earlier. So there's a lot of sensors which are being used, especially in VR and AR, but in IoT as well, to try to track people's bodies. And a lot of them use depth, like the Kinect uses a depth sensor or a time of flight sensor or a structured light sensor, whereas the Leap Motion doesn't use any of those things. It just gets images, and then our software is what does the tracking. And so the advantage of that is that the device can get much, much smaller, because it's not packing in all these different components. It's only got infrared LEDs and then cameras that pick up that bounce light. Everything else is happening in the software.
Yeah, and then we're, just for the audience, we're typically buying these Leap Motion, these controllers with the cable, and then the SDK we just download. We're buying these off of a large popular internet retailer for $40 or $50. So it's really actually pretty inexpensive for what you get.
That's another great thing about it is the components aren't very expensive, so you can put a bunch of them on a bunch of different projects if you like. But so to talk about what we're moving towards here with the headset.
One question about this. Where do you see this used a lot? Like where are people using these things?
So robotics is a big one. Basically, the way that Leap Motion started was trying to break down the barrier between people and technology by allowing them to use their bodies to control technology. So if you think about it from that perspective, the way that you were just using the robot arm, that's the perfect sort of use case on the desktop is having your hand take that data through the cloud and then put it onto a mechanical arm. So robots is a really big one because it offers a really intuitive way of controlling something. Another big one is at installations that are using projectors or something else where there's a big display and you want to be able to control it naturally. It's breaking down the barriers, like you were saying that there are 80-year-olds and 5-year-olds who are watching the show. instead of using a mouse and keyboard or some sort of other complex input, people can just use their hands. And so whatever you want to use, then you can transfer that data into a bunch of different things. Robotics and installations are some of the biggest ones. And then as we've moved forward, VR is becoming the next biggest use case for hands.
Awesome. So where do you see the industry headed, and what is it that you brought? Tell us a little bit about what you brought here.
Yeah. So this is an HTC Vive virtual reality headset.
Yeah.
And so this and the Oculus Rift are the two that people probably have heard of that are tethered PC headsets, meaning that you plug this thing into your computer and then you put it on in VR. You can look around and you feel like you're in a virtual space. And so the display side of virtual reality is something that a lot of companies have a hand in now. You've got this is a partnership with HTC and Valve. You've got Oculus and Facebook. You've got Microsoft with HoloLens. There's a bunch of people making the headsets and the displays. The next sort of frontier after that is input. How are you going to interact with these virtual spaces and virtual objects? And that's sort of where we come in. What I was talking about a second ago with being able to use your hands to naturally interact with things. When you put on a headset, at the moment, sometimes you've got to tap a touchpad on the side of the headset to select something. It's sort of like a mouse click cursor. Or you've got these controllers with buttons and joysticks, which are good for games, especially if you're a gamer, you know how to use those things. But as these technologies get bigger and bigger, and we start using them in our everyday lives, again, the 5-year-olds, maybe not 5-year-olds, maybe a little bit older, and the 8-year-olds, using a computer is becoming more easier over time, I think, and so we're a part of that timeline of computing becoming more like real life, and the interactions that you use to interact with your computer becoming more like the interactions.
Now that that doesn't actually look like a Leap Motion I've ever seen before.
Yeah,
so
you're right. So this is actually this piece of
maybe
hardware.
Hold it up. So
Yeah.
that, I don't know.
I'm not sure.
see.
We don't have
can-
Zoom capability.
How far does that
like
cable go?
It's not connected to anything,
not
so
connected.
you can
Yeah.
walk
So-
right up to the.
so here, watch
Maybe you
it.
can show like
Yeah, here, Martin, I got it.
Yeah.
So while you're kind of talking about what that is, I'll walk this over to the camera.
There you go.
Yeah.
You want to put it on and walk into the camera?
Yeah.
All right, so
Full man's virtual reality. Just close
all
your
right,
eyes.
so all right, I'll try and set. So there we go.
Yeah.
How's that?
So as I was saying, the hardware can get much smaller. So
Just before you do it, this is
Yeah.
the first time ever showing it, right?
this is one of the first times ever shown.
You can say this is the first time. This is the first time ever shown.
Worldwide exclusive. On the
So now
AWS thing.
this doesn't look like, it looks kind of rough. Is that for a is this how it's going to look in the end? Looks like maybe it's a prototype?
Right, it is, correct. So this is the Leap Motion consumer device, which has been on the market for 4.5 years now or so. That device is our second piece of hardware ever. And it won't be sold directly to consumers. So it's specifically for embedding in future virtual reality headsets. So the use case of hand tracking in virtual reality is so compelling that rather than make an all-purpose device, we focused on VR and on mobile VR to get our technology as a native input. So you won't necessarily even be asking for a Leap Motion device. You'll be asking for a virtual reality headset, and it will have this new sensor built into it directly.
So like a mixed reality almost. That's what I've been hearing that term a lot lately now.
Yeah, I mean, the industry is sort of in this weird space where people are grabbing for names to try to define things differently. It's VR, AR, mixed reality is sort of a catch-all term to some people. Then there's XR has become a new thing recently. Like, it's a very fresh space, so people are trying to come out with new products. And then I heard cinematic reality recently, which I'm not even sure how that is different. But yeah, and so the advantage on the improvements are on this piece of hardware. So this device has the cameras are a field of view of 135 degrees, which is pretty good for desktop use. You're not going to have your hand super far out. But on the headset, you want to be able to have your hands not kept right in front of you and have them much further out. So the cameras on here are 180 degrees by 180 degrees.
Wow.
So pretty much.
Any reason why the Vive over other products?
So actually, this is the headset I use at my desk. You can mount this. You can mount one of these devices. Sorry, I should probably say that. At the moment, if you have a headset, you can get one of these devices, and then you can either
Just put it like this?
Exactly.
Yeah.
Yeah. So you can either buy or you can 3D print, as this little housing is right here. 3D print your own mount, and then put it on the front of here. So this is kind of a maker thing.
If you can you pass us that CAD file for that 3D
Yeah,
print, and we'll
totally.
post it on our
that'd be awesome.
on our resources.
Yeah, which just anyway. Before we end, we're going to touch a little bit on 3D printing. So thanks for that lead in. So.
Yeah. Are there any questions from audience? So you want to make sure we cover.
There was a question earlier that Desmond Bradley asked if there's a Leap Motion product that could bigger range for motion sensing.
Bigger range, yeah. So like I said, we're focused on hands because that's the most useful sort of input of the body. We haven't ruled out other things to track yet, but at the moment I'd say Connect 2 is probably the best for wider body tracking, if that was the question.
So you're in the room and it'll connect, it'll track everywhere in the room, right?
So
So
I'm assuming like the Connect has like a pretty good range, but the Leap Motion has a very much more accurate range when it comes up close.
Exactly, it's a more focused device. So the Connect is trying to track your whole body.
Yeah.
And if you were to look at the tracking points on the Connect, it's got a big tracking point at larger distances on your body, whereas we're focused specifically on your hands and tracking them at a really high fidelity.
Yeah,
Great.
And Spaz Christ asked, can the Leap Motion detect, or can Leap Motion SDK detect certain hand gestures? I'm not sure what kind of hand gestures you're talking about, but it says it obviously detects all the fingers, but if you wanted to detect something or somebody wiggling their fingers, for example, would you have to make your own code for that, or is it like the iOS SDK that has specific APIs?
So we did that. So as we've built the various versions of the robot arm to take the end effector and have it open or close, there's different gestures that the Leap Motion SDK supports, like rotating your finger, opening your hand, closing your hand. So there's a number of
virtual tap. So I can do like this in the air, and it'll know that I'm sending a specific signal to it. So you can create a lot of them already come out of the box. I'm not sure if you can create custom actions.
Yeah, you can, exactly. So you can. There are things that we thought were obvious that people might want to use, like grab strength or pinch strength or air tapping or circle gestures. But like I was saying, because you have the position and orientation data of all those tracking points, you can combine those with a overtime call, and then you've got a gesture that you've defined yourself.
Nice.
Fantastic. So great.
So any other questions for Martin?
There was a question that said, can they work together? But I'm not sure if they meant, can the Connect and Leap Motion can work together, or can the APIs work together? The Leap and Connect, can they work together?
Yeah, I've seen the example of installations. That's a big one where people are tracking the whole body using the Connect, and then tracking hands using Leap Motion to get the whole body involved and then precise action. So yeah, definitely.
Cool.
Awesome.
Great.
Cool. So I think we are a little bit out of the time. I think we wanted to cover Leap.js. I mean, I can at least show where to find the resources, and hopefully in the next episode we'll cover them. Trevor, can you switch to my screen once?
Once?
Yep.
Just once?
Just once, last time. So one of the things which you would look for is just say type Leap.js SDK. So this is the JavaScript SDK of Leap. Once I go there, this is the client which we are using for detecting the signals which Leap Motion is generating, and then doing different things based on it. So if you look at some examples here, I would say just play with this piece, which is leap.loop, and then you're printing frame.hands.length. So what this piece of code will do is it will show how many hands are being detected by the Leap Motion right now. Like I have all that running in my laptop, but in the interest of time, I don't want to stretch it forever. But in the next episode, we'll go deeper into this. One more thing which I'll tell is say Leap.js hand. Let's call it hand. So it will tell me more about different things which a hand can do. So let's look into Leap hand. So there are different things here, like how hands work. I think there was a question about what are the gestures you can check here. So there's another library called JavaScript V2. So and I think we will post all these links. But this gives a very good idea of what Martin was talking about. Like there's something called grab strength, for example, and you can read what it does. It's the strength of grab, like how tightly your hand is closed and how open it is. Similarly, there are a lot of other things like.
So what, pressure?
Yeah, so you can detect whether my hand is closed or not, for example.
How closed it is.
It'll be the distance between your palm and the tips of your fingertips.
Yep. So the more you close, the higher the grab strength becomes, or vice versa. So and then it has a lot of other things. For example, where's your palm, like how high it is. So there are a lot of things which we can detect here. But for now, I'll just say play with this, just check out what Leap.js can do. And in the next episode, we'll connect whatever Leap motion code we have and what are the things which the cloud can do. We'll connect them together and send all the Leap data into the cloud. Does that sound good, Tom?
No, that sounds great. Yeah. So
we have another guest coming.
yeah.
Next
So
week.
that's a great lead-in. So next week we're going to kind of extend the solution a bit further, and our special guest is going to be Dave Evans from a company called Fictive. And they're kind of reimagining 3D and other types of additive and subtractive manufacturing. So Dave's an expert in that field. He co-founded Fictive. He's going to come on board the show next week and tell us a little bit about how to do things like make your own enclosure for your own IoT device. So that should be really fun.
Wow, 3D printing, like going very deep.
Yeah.
And they printed a motorcycle, right?
Oh yeah, we'll talk about the motorcycle.
Thanks, Anupam.
Yeah.
That was a surprise.
So anyway, a little bit of a teaser. Search Fictive open source motorcycle, and you'll get a sense of.
Yep. One more thing which we'll have differently in our next episode is I'll be traveling, so I'll join remote, and we'll see how it works. But I'm super excited that if we can make remote things work, we can have a variety of guests who can join us from different places. So
we wanted Anupam to have. We wanted like a mannequin with a screen with just his head being remotely remoted in, but it's not going to work.
Yep.
Yeah.
Hope someday we will create a robot like that.
We dress you up too. We dress you up real nice.
Yep. So one thing which will help us is if there are specific pieces where you want us to dive more, because the next episode we're going to go deeper into the cloud piece. Because today we just showed how to send and receive data. We'll go more than that. And then we'll also focus on 3D printing as well as how to write the code of Leap Motion.
Great. Awesome.
Thanks for joining us.
Oh, thank you, Martin, for coming by.
Thanks, Martin.
Thanks, Martin.
Appreciate it.
Yeah, for sure.
All right.
Cool.
All right. Take care, everybody. Until next week.
All right, it's not going. What is
Should we ask? Alexa, what time?
Preview.